Hello, everyone. I am Alikhan. I am a second-year PhD student at the University of Washington. Today, I will be presenting the paper Begone, Orthot, a near-future exploration of bodily autonomy. This paper uses design fiction to speculate about the future of cyborg technologies and biohacking, and touches upon both the potential civilian and military applications of what a technology like this would look like in the near future. This paper also talks about what bodily autonomy post-implantation would be, questions about the right to repair, and what shared liability would entail in these conditions. I will start with a brief discussion of design fiction as a method of use to us in HCI. We can contextualize our current norms and illustrate the possible consequences of emerging technology through design fiction and speculation. We are able to interact with the future that could materialize if we do not critically assess the function that emerging technologies will play in our society through scenarios that elicit critical reflection. Product innovation happens so quickly that legal guidelines governing its use may become outdated before they are even completed. Because of this, it is crucial to have conversations about what constitutes an ethical boundary for these kinds of technologies before they become widely used. Cyborg technologies have been defined by Liam Naughton and Herbert Daly as a functional synthesis of the biological and the technological, a living creature that has both biological and technological components. In 2010, Roger Clark put forth a framework for defining technological interventions that are used to enhance the human body and experience to better understand cyborgs. Clark posits that this technology can be divided into the following: prosthetic and orthotic interventions, and then further subdivided based on the level of integration within the body. Orthotics, which Clark has defined as an artifact that supplements or extends a human's capabilities, are relatively common, with a simple example seen in infrared or heat-sensing goggles, allowing people to see in the dark. Prosthetics allow for an inherent functionality of the body previously missing or otherwise defective to be restored, such as an artificial limb in place of one lost. Biohacking is a practice of science that can merge body modification with technology for cybernetic exploration and accessing cyborg capabilities. The timeline I have here is to support us through the transition of real discussions of cyborgs over to the design fiction itself. This figure provides a timeline of a few major milestones within the cyborg space and extends to a fictional future that could exist if the commercial viability of providing permanent embedded technologies became clear to major tech companies. The 2010s saw an emergence of biohacking activities through unconventional, unregulated, and uncontrolled procedures grounded within emerging technologies that were often self-administered. A subset of biohackers called grinders emerged with the aim to enhance themselves by assimilating emerging material technologies, including but not limited to electronics, with their bodies through experiments and surgeries. I used this image that I created of the first page of a patent filing as my design artifact, which I think is an appropriate artifact, as patents are sort of speculative design by nature when they do not necessarily exist yet. This fictional technology would provide a system of implants that work in a supportive capacity to nullify the burden placed upon many organs in the human body, with the caveat that the recipient of this fictional Febris implant pays a monthly subscription for its continued function. The suite of interventions consists of a series of attachments to organs throughout the body, though the brain is excluded. The control panel signals for the acceleration and deceleration of the efficiency of function of any organ, with the assistance of the attachment and allows the user to have full reign over their hormones within non-lethal limits. To apply Clark's framework, these would be considered an endo-orthotic intervention, as they extend capabilities of parts of the human body that are key to its continued function. One point of this design fiction considers what the right to repair would be in this world. As with any for-profit company, this Febris company ostensibly would aim to have year-over-year growth of their profit margins. Therefore, what is the incentive for designing for longevity or even ease of repair? Unlike a device like a smartphone, the disposal of this technology would likely be invasive or costly, meaning that many people may not choose to upgrade and sales could stagnate. Logically, where does it leave the growth of this company? Donna Haraway mentions that one should expect control strategies to concentrate on boundary conditions and interfaces, on rates of flow across boundaries, and not on the integrity of natural objects. Questions of boundaries and the way in which they may be crossed run abound when the mechanisms with which to control others become explicitly manifested within the world. This leads us to 3 different questions. Question 1. We would hypothesize that grinders may be willing to be in the first wave of users for endo-orthotic technologies, since there is a clear inclination towards allowing technology to be embedded into the body. However, would technology that are developed by corporations be accepted by grinders? The norms that are put in place for embedded technologies, such as Neuralink or our fictional one, Febris, would likely be encoded by the companies themselves. And this may be a point of tension that would limit the adoption rates of grinder populations long term in a way that may not impede the adoption rates for the general population. Question 2. How will this desire to break free of societal norms interact with the prevailing laws? Febris implants as a tool would be a simple way of retaining access to gender-affirming care. Orthots would be able to adjust their estrogen or testosterone levels as desired, with nobody able to bar access to medications, no prejudiced practitioners denying requests to receive gender-affirming care. The fictional release of this technology is placed 40 years into the future, hopefully well past the time that restriction on access to gender-affirming care are lifted. Ponder the alternative case that they are not. With the knowledge that this technology could be used to assist with gender-affirming care, would there be backlash or bans forbidding usage in this way? Would Febris have to release a version of the technology that does not allow for this adjustment? When would people be allowed access to the technology installation? Would children be allowed to enhance their bodies in any way? Is it possible to predict what the psychological ramifications would be of growing up, enhancing yourselves by means of technology continuously? Theoretically, the Febris Suite would not allow the user to truly hurt themselves, but will we trust children to be able to control their own bodies? Children are allowed to be enhanced. Would enhanced children have their enhancement settings controlled by their parents? And if so, would this stop at the age of majority? Would people who have received the implant as a result of the time that they had spent in the military ever receive access to fully control their own implants? The potential for abuse when someone has not just viewer access, but editor access over the body of another is chilling. HCI researchers and designers may benefit from engaging with questions of long-term psychological effects of emerging technologies that they explore in their own work, as well as the power dynamics at play when it comes to the control of those technologies. We have additional findings that we cannot include here. These can be found in the full body of the paper.